Hi everyone, welcome to today's class. Today we are going to discuss about the exercise in a combustion field. It states that a gas engine operating on methane at 1500 rpm full throttle generate the following emissions measured on dry volumetric basis: CO2 10.4%, CO 1.1%, H2 0.6%, O2 0.9%, NO 600 ppm, HC 1100 ppm as methane. If the specific fuel consumption is 250 gram per kilowatt hour, calculate the specific emissions of carbon monoxide, nitrogen oxide, unburned hydrocarbon, that is in gram per kilowatt hour. Why is this specific basis more relevant than a percentage? So first we have to write the given data. Fuel is methane CH4. Then speed of the engine is 1500 rpm. Specific fuel consumption 250 gram per kilowatt hour. Then operating condition is full throttle. The product of combustion is CO2 10.4%, CO 1.1%, H2 0.6%, then O2 0.9%, NO 600 ppm, HC 1100 ppm as methane. These emissions are measured dry volumetric basis. And the first one is specific emission of carbon monoxide, nitrogen oxide and unburned hydrocarbons. The second one is why this specific basis is more relevant than of the percentage basis. NO and HC they given in parts per million. So we have to convert this parts per million into percentage by volume. 1% by volume is equal to 10,000 parts per million. So this is equal to NO in percentage volume 0.06. This one is 0.11 percentage volume. Now assume that water vapor and nitrogen will be present in the exhaust. The combustion equation becomes, so this methane reacted with air to produces 1.1 percentage of CO, 10.4 percentage of CO2, 0.6% of H2 and 0.9% of O2, then 0.06 NO and 0.11 CH4 and A amount of H2O and B amount of assume that MCH4 NO2 plus 3.76 N2. So in this case, first we need to find out what is the amount of methane, what is the amount of air, what is the amount of water vapor and what is the amount of nitrogen present in the exhaust. So that to find these things, first make a carbon balance. M is equal to 1.1 amount of carbon monoxide, then 10.4 amount of carbon dioxide plus 0.11 amount of methane as unburned hydrocarbon. It will be producing 11.61 kilomole of fuel. The unknown term is nitrogen, water and air. Second, you make a hydrogen balance, H balance. So we can say that what it is, M into 4 is equal to 0.6 plus 0.11 into 4. So already we found that M is equal to 11.61 multiplied by 4 is equal to 0.6 plus 0.11 into 4 plus 2A. We found that A is equal to 22.4. For oxygen balance, we can say that 2N is equal to 1.1 plus 10.4 multiplied by 2 plus 0.9 multiplied by 2 plus 0.06 plus A plus A. So upon simplification, we can say that this one is 23.76 plus A is equal to 2N. Already we found that A value is equal to 22.4, so 2N is equal to 23.76 plus 22.4, then N is equal to 23.08. Now the amount of air. Now the unknown term is the amount of nitrogen in the emission. So now when you are making a nitrogen balance, we know that N amount of air into 3.76 multiplied by 2 nitrogen is equal to 0.06 amount of NO plus B into 2 nitrogen. So N already we know that 23.08 into multiplied by 3.76 multiplied by 2 is equal to 0.06 multiplied by 0.06 plus B multiplied by 2. We can get this B is equal to 86.75. Now the combustion equation becomes 11.61 kilomole of CH4, 23.08 amount of air to produce 1.1 CO, 10.4 CO2, 0.6 H2, 0.9 O2, 0.06 NO, 0.11 CH4 and 22.4 H2O, 86.75 N2. Now we observed from this equation 11.6 kilomole of methane produces 1.1 kilomole of CO. Therefore, 1 kilomole of CH4 produces 1.1 divided by 11.61 kilomole of CO. When you're coming into the mass basis, first we have to identify what is the molecular weight of each constituent. So the molecular weight of methane is equal to 12 plus 4 is equal to 16. Then molecular weight of carbon monoxide 28. Molecular weight of carbon dioxide is equal to 44. Molecular weight of nitrogen oxide is equal to 30. Molecular weight of H2 is equal to 2 and molecular weight of O2 is equal to 32. Molecular weight of H2O is equal to 18. Molecular weight of N2 is equal to 28. Now we come to here. The 1 kilomole of methane to produces 1.1 over 11.61 kilomole of CO, that is equal to 1 kg of. So the emission of CO is 0.1658 gram of CO per gram of methane. Now the specific emission is equal to 0.1658 gram of CO divided by gram of methane. Then specific fuel consumption 250 gram of methane over kilowatt hour. So we can get 41.45 gram of CO per kilowatt hour. Similarly, the specific emission of NO 11.61 kilomole of methane produces 0.06 kilomole of NO. Then 1 kilomole of methane produces 0.06 over 11.61 kilomole of NO. Now 1 kg of methane produces 0.06 multiplied by 30 over 11.61 multiplied by 16, that is equal to 9.6899 10 to the power minus 3 kg of NO. So that 1 gram of methane produces 9.6899 into 10 to the power minus 3 gram of NO. The emission of NO is 9.6899 into 10 to the power minus 3 gram of NO per gram of CH4. Then specific emission is 9.688 into 10 to the power minus 3 multiplied by 250. We can get 2.42. We can get 2.42 gram of NO per kilowatt hour. Similarly, the unbonded hydrocarbon in terms of methane in the exhaust CH4, 11.61 kilomole of methane is come out as exhaust as 0.06 kilomole of methane. Then the methane emission is 0.06 over 11.61, that is equal to 5.1679 multiplied by 10 to the power minus 3 gram of methane per gram of methane. Now the specific emission is 5.1679 multiplied by 10 to the power minus 3 multiplied by 250 gram of methane kilowatt hour, so that we can get 2.368 gram of methane per kilowatt hour. So that the first question is the specific emissions. The specific emissions is carbon monoxide, nitrogen oxide, unburned gram of CO per kilowatt hour. Then this one is 2.42 gram of NO per kilowatt hour, 2.368 gram of unburned hydrocarbon per kilowatt hour. Now the second question is, why we are making a specific emissions than volumetric basis. The engines are supposed to produce the work and power, so that it is better to use this emission in terms of gram per kilowatt hour instead of volume basis. So it is preferable to use the work or power than that of the volume basis. From the present exercise, we found the specific emission of carbon monoxide, nitrogen oxide and unburned hydrocarbon in terms of methane. Then remaining specific emissions like carbon dioxide, hydrogen, water vapor and nitrogen we can find in the similar way. This is the over.
Subscribe to our channel, like if you're satisfied, and share because it may useful to someone.